Hello everyone, I am Hassan Rahman and I shall present our paper entitled Predicting the Evolution Periods of Verses of the Quran via Deep Learning. Knowledge of the revelation periods of verses of the Quran helps Muslims to understand prophet sections, applicability of Islamic laws, interpretation of Quranic verses, etc. That's why many Islamic scholars tried to identify revelation periods of Quranic verses. They mostly relied on finding unique words, phrases, or topics of verses, or employed historical documents for this purpose. With the advent of modern deep learning based NLP techniques, it is now possible to learn more complex patterns, which may help us to classify verses better. Moreover, no such work has been done before. These facts motivated us to work on this project. Quran is the main religious book of Islam. Quran was revealed to Prophet Muhammad, peace be upon him, by Allah between the years 609 and 632. He lived in Makkah during the first 13 years of his prophetic mission and then he left for Medina. Verses revealed in Makkah are called Makkan verses and those revealed in Medina are called Medina verses. We attempt to predict revelation places of Quranic verses, basically classifying those verses into Makkan or Medina phases via deep learning techniques. To the best of our knowledge, a few papers try to classify Quranic chapters. There are few other works that classify verses of the Quran into major topics or themes discussed in the Quran. However, we found only one work which classified Quranic verses into Makkan or Madinan phases. However, they only applied traditional machine learning classifiers on Arabic Quran verses, and they measured their classifiers' performances using accuracy only. In contrast, we employ deep learning techniques to classify both original Arabic verses of the Quran and an English translation of those verses. And we measure our model's performance using multiple metrics, not just accuracy. We collected Arabic verses of the Quran from Tanzil.net and we crawled Quran.com to collect an English translation of the Quran. Thus, we create two datasets of Quranic verses, one Arabic and another English. We label those verses as either Makkan or Madinan or unlabeled by using some books on the sciences of the Quran. Here, the unlabeled verses are the ones whose revelation periods are still debated among scholars. As you can see, the number of Makkan verses in our dataset is 2.79 times the number of Madinan verses, i.e., there is a class imbalance issue here. Later, we shall discuss how we deal with this issue. At first, we represent our datasets using word clouds to identify words which are frequent in Makkan verses but not so in Madinan verses and vice versa. We identify several such words in Makkan verses such as sign, Moses, Pharaoh, heaven, worship, etc. These results make sense because Makkan verses focus on afterlife, stories of previous nations, worshiping Allah alone, etc. In contrast, we find words such as woman, believer, believe, etc. characteristics of Madinan verses. These results also make sense because many Madinan verses contain the phrase, "O you who believe." Another unique feature of Madinan verses is discussing legal issues of women. Since our dataset contains many unlabeled verses, we employed a deep learning-based semi-supervised classifier to see if incorporating the unlabeled verses into the learning process improves classification performance. We show the classification algorithm here. At first, we apply a bar-based model on 70% of our labeled dataset to train that model. Then we call this model the student model. Then in a loop, the student model is copied to another model called the teacher model. And the teacher model is then applied to some randomly selected unlabeled verses to obtain their class probabilities, which are combined with labeled verses to train a newly initialized BART model. That BART model is used to replace the student model. This process continues until all the 232 unlabeled verses are used for training. The student model is trained to optimize a weighted loss function mentioned here. This optimization process tries to balance knowledge gained from labeled verses and the knowledge gained from previous iterations. The loss function mentioned here is basically the binary cross entropy loss function. Here, W1 represents weight of Modinan versus W0 is the weight of Makkan versus. In the original model, both weights are the same. But to deal with the class imbalance issue present in our dataset, we also created a weighted version of this model where we assign weights in such a way that the weights are inversely proportional to the class sizes. In the first line of our algorithm, we employed a BART model, remember? But we have two datasets, one English and another Arabic. So when we apply this algorithm on our English dataset, we use BART-based uncased model in this line, whereas for our Arabic dataset, we employ Camel-Bart CA model here. We employ Camel-Bart CA model for Arabic because it was trained using text written in classical Arabic, which is Quran's language as well. Finally, notice that this part of the algorithm is responsible for semi-supervised learning. By omitting this part, we also created a supervised version of the model. Thus, we have total 8 variations of the chosen model that differ either by dataset, English versus Arabic, or by weight, unweighted versus weighted, or by the learning process, supervised versus semi-supervised. We apply those 8 models on our datasets, and since the prediction performances of these models vary from one run to another, we took the average performance scores over 3 runs of each model. We present Mach-Kan precision, Mach-Kan recall, Modinan precision, Modinan recall, Mach-Kan F1, Modinan F1, average precision, average recall, average F1 accuracy, as well as the ROC curve and precision recall curve. We observe that English models typically exhibit slightly better performance than Arabic models because in our English dataset, pronouns are reserved and certain phrases have short interpretations that are absent in Arabic. Also, another reason is English model was trained with billions of English words, whereas the Arabic model was trained with a few hundred millions classical Arabic words. We also see that Markov precision recall and F1 score are always better than Modinan ones. This also makes sense because majority of verses are Markov verses. Unweighted models outperform our weighted ones in most metrics because of the higher prediction performance on Markov verses. However, weighted models tend to reduce the effect of class imbalance issue. As you can see, Modinan recall and Markov precision in weighted models are typically greater than those in unweighted models. In other words, weighted models increase both Modinan recall and Markov precision, meaning fewer Modinan verses are misclassified as Markov verses as compared to the corresponding unweighted models. These results make sense because in weighted models, class weights are inversely proportional to the class sizes. So classification errors and Markov verses are seen by the weighted model as less serious than those on the Modinan verses. Finally, we also observe that adding unlabeled samples does not always improve classification performance. Probably the reason is that the unlabeled verses are hard to match with either Markov or Modinan categories. It explains why it has been so hard for Islamic scholars to classify those verses for over 1,000 years, and still there are debates around those. In future, one can apply other machine learning or deep learning models to predict repetition classes of verses. One can predict repetition classes of Quranic chapters rather than verses. One can predict more specific repetition periods of verses or chapters of the Quran, not just Makkan or Madinah pages. Our results show that it is possible to classify Quran's verses with higher accuracy using deep learning techniques than those achieved by the previous work that used traditional machine learning techniques. Thus, our work gives important directions for future work on this topic. Thank you.